Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Rock 4D from Radxa. This is a new octa-core ARM single-board computer with a hardware specification that may make it a strong competitor to a Raspberry Pi 5. So let's go and take a closer look. Right, here we have our Rock 4D, and specifically this is an 8GB model which sells on AliExpress for $75.64 and which cost me £57.37. But there are also versions of this board with 2, 4 or 16GB of RAM which cost $37.91, $51.52 or $127.34. So let's open this up, and I think I'll bring in Mr. Scissors and just snip a little bit at this stuff, this shrink wrap. Not quite sure how to get into this really, but must be a way in. Is that going to do it? Hopefully. Oh yes, we're doing great guns now. I can get in eventually. And come on, here we are. There we are, our new single board computer. And there it is in a little bag inside. Let's get it out of there. It's like Christmas, isn't it? And is it sealed? No. And here we have our brand new single board computer, which as we can see has got some antennas attached. And as we can also see, it has got a Raspberry Pi form factor, so let's put it down over here next to a Raspberry Pi 5. This shows us how the boards both have identical USB and Ethernet connectors on the end. They've both got a USB-C power connector, a 5V USB-C power connector, and they've both got identical PCIe connectors on the end of the board for connecting things like M.2 adapter boards to take an NVMe SSD. However, we can also spot some immediate differences. Not least, we've got a 3.5mm audio jack on the Rock 4D, hurrah, and we've also got a full-size HDMI connector compared to the 2 micro HDMI connectors we find on a Raspberry Pi 5. In terms of SoC, the Pi 5 has then got a quad-core BCM2712, whilst the Rock 4D has got an octa-core RK3576. So let's now delve more deeply into exactly what's on this board. As just noted, at the heart of the Rock 4D is a Rockchip RK3576 system-on-a-chip. This contains 4 ARM Cortex-A76 cores clocked at up to 2.2 GHz, along with 4 ARM Cortex-A53 cores clocked at up to 2 GHz. There's also an ARM Mali G52 MC3 GPU and a 6-TOPS MPU. Along from the SoC, we then have our RAM, here 8GB of low-power DDR5, and next to that, a wireless module which offers Wi-Fi 6 and Bluetooth 5.4. Also on the top of the board, there's a 2-lane MIPI CSI connector for connecting a camera and a 2-pin fan header. On the first short edge, we then have 2 Type-A USB 2 ports and 2 Type-A USB 3 ports, the uppermost of which offers OTG functionality. And we also have Gigabit Ethernet with Power over Ethernet support. Spinning 90 on the main lung edge, there's then our USB Type-C power connector that requires a 5V input at up to 5 amps, and then next to that, our full-size HDMI connector, which is HDMI 2.1 and supports up to 4K output at up to 120 frames a second. Finally, we then have our 3.5mm audio jack with a microphone input as well as stereo output. Quarter turning again, at one end we find our Wi-Fi and Bluetooth antenna connectors, and at the other end indicator LEDs and a power switch. And then in the middle we have our PCIe connector, which is single lane PCIe 2.1 and should be directly compatible with Raspberry Pi 5 PCIe peripherals. We shall see. And then finally, on the second lung edge, there's a colour-coded 40-pin GPIO header, which is again Raspberry Pi compatible, and a 4-pin Power over Ethernet header. If we return to the top of the board and then turn it over, that'll catch it out, won't it? Under here we find various things you might have thought were missing, including a microSD card slot. Well, you probably expected that, but we also have here a second MIPI CSI connector, this one 4-lane for connecting another camera, and also a MIPI DSI connector, also 4-lane for hooking up an LCD panel. And so overall we have more MIPI connectors than on a Raspberry Pi 5. Also underneath we have a real-time clock battery connector, and we also have this, which deserves a bit more of our attention, as whilst it looks like the eMMC connector found on many SBCs, it can take either an eMMC or a UFS module. In case you're not in the know, and I've learnt a lot about this whilst preparing this video, UFS or Universal Flash Storage is newer than eMMC or Embedded Multimedia Card. UFS offers the advantages of using less power, being available in higher capacities, and it's a lot faster as it has a bidirectional full duplex interface compared to half duplex for eMMC. Hence, whilst eMMC speeds are typically around 250 megabytes a second, Radxa sell UFS 3.1 modules that will work with the Rock 4D with an advertised read speed of 2100 megabytes a second and a write of 1800 for their 512 gigabyte media. However, sadly, I can't find one of these UFS modules in stock anywhere, so we can't perform a test. And we probably can't even test the speed of an eMMC module on this board, even though I have one available. And this is because if we visit the Rock 4D webpage, whilst if we scroll down to compatible accessories, here we are, we do find under here eMMC modules. But if we then scroll up and keep going, and there we are, we discover that eMMC modules are only supported when SPI flash is not present. And I think we do have SPI flash on our Rock 4D, and so I don't think an eMMC module will work. Anyway, back on wider matters, Radxa say that the Rock 4D is intended for industrial AI and edge computing, but is also perfect for hobbyists and makers. It's also advertised with a guaranteed availability to 2035, so should be around for some time. Finally, there are also two versions of the Rock 4D, the commercial version, which is the one we have here, which is based on the RK3576, but also an industrial grade board, which is based on the RK3576J. The latter can apparently be used in a more extreme range of temperatures, and with all this noted, let's go in search of an operating system. Greetings! Here I am back again. I've now got the board connected up, as you can see. I've got an operating system image to a microSD card, and I've also fitted a heatsink. Radxa do sell a cooler you can use with this board, which has got a heatsink and a fan, but I forgot to buy it, so I've just fitted a heatsink, one of these 25 by 25 by 10 millimeters, and I do have a fan available. Here it is, little 25 millimeter fan will go on top of this. It doesn't have the right connector on it to connect to the fan header on the board, but I can rig something up maybe from GPIO, something like that, but I'm not sure I'm going to need a fan. Anyway, I'm sure what you want to see is this board up and running, so let's turn on the power. There we go, little LEDs are coming into life, and what we're booting into here is Radxa OS, which is actually Debian with a very interesting choice here of desktop environment. Let's see what you think of this. And we will boot up in real time, so you can see the speed of a boot into Radxa OS from a microSD card. We're getting there, he says as we look at the black screen, but there we are, we can now log in. For some reason there are two users available on the default image. I've been using the first one, which is Radxa, which has a default password also of Radxa, like that. If I can put it in correctly, I can. And you will now see the desktop environment we're going to get. Yes, it has got KDE Plasma. I don't think I've ever run KDE Plasma on a microSD card on an SBC before, but it actually works pretty well. This is a rather nice system. I'll just bring up a menu and you'll see very KDE Plasma, isn't it? And it's not bad at all. And what I thought we'd do here is first of all to have a quick look around and do a quick test of things like streaming media playback. And then after that, I thought we'd see if we could use an NVMe SSD in a Raspberry Pi adapter board. And after that, I thought we'd do some tests directly comparing the performance of the Rock 4D with the Raspberry Pi 5. But first, let's have a little look around at this lovely system. Let's just bring up a file manager because it's always nice to see. It is a beautiful desktop KDE Plasma, isn't it? It really works very nicely. In terms of what's pre-installed here, there isn't a great deal. There are the basics we need. There are a couple of browsers, Chromium and Firefox. There is a media player. We don't have LibreOffice pre-installed. There are various settings as you would expect, including this utility from Radxa for configuring the system. Let's just put our password in. This does all the basic sort of stuff you would imagine. We won't go further than that, but you can see that is there, which is good. Where were we in the menu? We were down in settings, weren't we? And then after that, we've got system. I'm sure some of you might want to see Info Center. This shows us what's going on. There we are running Debian 12. Debian 13 is launching almost about the same time this video goes live, I think. We'll have a look at Debian 13 on this channel very soon. But for now here we're running Debian 12 with KDE Plasma version 5.27.5. We're running kernel 6184, etc. And we've got our 8 CPU cores, 8 GB of RAM and Mali G52 GPU as we expected. So let's close that down and just go back to the menu because some of you will want to see 8-top running, I'm sure. So let's give you a fill of 8-top. You can see the processors running on this system. We're using just over half a gigabyte of memory to do nothing. It's amazing, isn't it? That used to be a massive amount of memory. These days, we've got 8. We can use half a gig just to keep things going along. Anyway, I've been wittering there long enough for some of you who want to actually investigate, look at 8-top. It's gone now. You can't get too much of a good thing. And I think we'll now launch a browser. I found that Chromium gives better streaming media playback performance on this system than Firefox, so we're using Chromium. And as you can see, to save time, I've preloaded this page, which shows us we've got a good level of hardware acceleration. And I've also preloaded this page, the Christopher Barnett YouTube channel, because it contains my test clip. Let's have some ducks in this video. And as you can see, this is a nice responsive system. It doesn't feel like your average SBC. Let's make sure we're in initially 1080p, and we'll bring up stats for nerds and let the system settle, as it will in a second. There we are. And now it's settled. It's playing 1080p, no problems at all. This is a clearly very good media playback. Nice smooth transition there. And we can even go here to 4K without any problems, I think. Let's go to 2160p. And we'll just also go back a bit because we'll run out of video if we're not careful. This poor system's got so much to do, hasn't it? I'm cruel to computers, make them do all these things at once. But anyway, it'll settle in a second. Come on, settle for us. You can do it. There we are. It did my bidding there, didn't it? And as you can see, once it's settled, we do not have drop frames at 4K either. This is very good streaming media playback performance. Look, I say that and it gives us a little glitch, doesn't it? But once it has its little glitch, okay, 4K isn't perfect, but 1080p was good and 4K is just about usable. Anyway, this gives you an idea of things like this on the Rock 4D, so let's now move on to some storage tests. Right, I've now tried plugging in our eMMC module and it doesn't work. And so, as most of the documentation makes clear, you cannot use eMMC modules on the Rock 4D, you have to use a UFS module, and I look forward to getting hold of one of those and testing it out in the future. But for now, what I have got successfully working is a Raspberry Pi M.2 HAT, which, as you can see, I've fitted to the Rock 4D with a Raspberry Pi SSD fitted. So let's go across to the desktop, and this is actually a fresh install of Radxa OS running from the SSD, and it was very easy to get that working. I just had to image the operating system to the SSD, plug it in, and it booted no problems. No configuration to do at all. So let's bring up a terminal, and first of all we'll do an ls PCI to view the PCIe devices on the system, and there we are. We can see the Raspberry Pi M.2 HAT, which has got a Samsung controller. There it is. And we'll also do an LSBLK to see the block devices on the system, where we can see our NVMe drive. I don't have the microSD card plugged in right now, so we can just see the NVMe drive. And I think we should test its speed. Let's bring up the command. There it is in the buffer, the HD parameters command to test the speed of our SSD. So we'll execute that. And do remember, this is a single lane PCIe 2.1 interface, so don't expect anything spectacular, but 301 megabytes a second. That's not too bad. And I think I will now plug in a microSD card, which will just take me a second to get that in, and like that. Oh look, it's appeared. That's good. Let's just clear the screen to be tidy and do an LSBLK again. And there we are. We can see our microSD card. It's a SanDisk Extreme Pro model. So let's test the speed of the card, which is effectively the speed of the interface here. We'll just go back to the command and change that to eMMC BLK1. And here we go. What are we going to get? We get about 80 on a Raspberry Pi 5. So how's it going to compare? 65.84 megabytes a second. Not too bad. Not as fast as we see on a Raspberry Pi 5, but faster than I've seen on some other single board computers. Right, here we have a table that shows the results of some CPU tests I've run on the Raspberry Pi 5 in previous videos, and we're going to repeat these on the Rock 4D. If you can hear a slight whining sound in the background, it's because I've reconfigured the board with a fan on top of the heatsink, because when I tried running these tests earlier without the fan, the board throttled, and so we've got the fan jerry-rigged to the GPIO pins to power it, because I haven't got the right lead to connect it to the fan connector. So the fan's being a bit noisy at the moment, but at least it means our tests won't be corrupted. So let's go across to the desktop, where I've got pSensor monitoring our temperatures, and we'll go to the terminal, where our first test is going to use sysbench to factor prime numbers with an events limit of 10,000. And note that here threads is set to 8 because we've got 8 cores on the Rock 4D. It was set to 4 on the quad-core Raspberry Pi 5. So let's run this test. Should only take a few seconds, something like that. There we are, 2.03 seconds. And if we put this across onto the table, we see it's a slight win for the Rock 4D. So let's go back to the terminal, and we'll clear the screen to be tidy, and we'll now run the Geekbench test. There it is, and this will take somewhat longer to run, and so we will now speed on through. And there we are, it's finished. And because we're running on an Arm SBC, we have to look at the results in a web browser. So we'll just do that. And there they are, 324 single core, 1330 multi-core. The higher the result, the better. And if we put the results onto our table, we see we get 2 clear wins for the Raspberry Pi 5. So let's now move on to our next test, which is Silverbench, and this is a web-based CPU ray tracing test. So let's kick it off. And once again, we'll speed on through. And there we are, it's finished with a score of 3087. Once again, the higher the score, the better. And again, if we put this result onto our table, it is a win for the Raspberry Pi 5. Next, let's do some local tests. Let's close down this browser, we'll close down the terminal as well, and we'll run up GIMP, the GNU image manipulation program, which runs very nicely on this system. Still version 2.10 here, but runs perfectly well. There we are. And we'll go to File and to New. We'll do a 1080p default image, and we're going to go to Filters and Render and Lava, and we're going to render the lava filter on the default settings. So let's bring in a clock and press OK. And there we have our result, which once again we'll put onto our table, and which once again gives a win to the Raspberry Pi 5. But who knows what will happen in the final test? Well, you can probably guess, but we will see. We will now get rid of this, and we will run up Kdenlive, the video editor, which works very nicely on this system, using proxies, but using proxies it works very nicely. It'll come up in a second. There it is, look. And I've got my standard test edit sitting here. There it is, and it plays no problems at all. It'll play a transition in a minute just to show you how it works. It's working nice and smoothly. That isn't bad on a single board computer. I'm pleased with that. But anyway, we're here to run a test, so we'll go to Project and Render, and I've set up my standard script. So we will run the script like that, and as usual, speed on through. And there we are, it's finished in a time of 2 minutes 16 seconds. Which, if we put across onto the table, means it almost beat the Raspberry Pi in that test. The boards were very close, but once again it's a win for the Raspberry Pi 5. And so overall, I think we can safely conclude that the Raspberry Pi 5 is the more powerful ARM single board computer, but the Rock 4D is certainly in a similar territory. It's a nice board with which I continue to be impressed. Compared to a Raspberry Pi 5, the Rock 4D has minimal software support, with the official images currently only including Radxa OS. Although, as we've seen, this is pretty decent. And the potential to use a UFS module is also still very exciting, I think. Even though I haven't been able to do that in this video, I do look forward to getting hold of a UFS module in the future and trying it on the board, which in theory will increase the speed of the system drive by a factor of 7. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.